So we've already done problems A, B, and C. Let's look at problems D and E. Let's look at D first. In problem D, we've got 3 to the x minus 5 plus 4 equals 14. So again, the first thing that we're going to do is we're going to get rid of that plus 4 that's dangling off to the side. So we'll subtract 4 from both sides. That will give us a 3 to the x minus 5 equals 10. Then the problem is, how do I get rid of that 3? Again, that base 3 is an exponential base 3. So the only way to get rid of it is with its inverse, which is a log base 3. So what that does, if you do a log base 3 to both sides, is the log base 3 and the 3 with your exponential will cancel out, leaving you with the x minus 5 equals your log base 3 of 10. And if you were to continue solving this just to get your x by itself, the last thing you need to do is add 5 to both sides. And that would get me that x equals log base 3 of 10 plus 5. Now the only real question is depending on how the question is worded, are they okay with you leaving that log base 3 of 10? If they aren't, and they want either an LOG log or an LN log, well, then you have to use your change of base. If they want an LOG log, it would be LOG over LOG. Remember, the base, the 3 has to go on the bottom. The other number goes on top. And then you still have your plus 5 off to the side. Nothing else would change. But basically, those two answers mean the same thing. It just depends on what kind of format they tell you that they want. Now let's look at problem E. On problem E, let's take a look. We've got 3 to the x minus 4 equals 7 to the 2x plus 5. The problem is using a log base 3 on one side would only get rid of the base of 3. Using the log base 7 on the other side would only get rid of the base 7 on the right-hand side. And with equations, whatever you do to one side, you have to do the same thing to the other. So I can't do a log base 3 on one side and a log base 7 on the other. I can't mix and match. And it would be awesome if I could do some kind of common denominator, but that doesn't work either. So instead of trying to deal with the 3 or the 7, you say, forget it, let me just do a generic log to both sides. And by generic, we mean we can either do an LOG log or a natural log, the LN log. It doesn't matter which. It's just whatever you do to one side, you have to do the same thing to the other side. I've been using the LOG log a lot, so let's keep on doing that. So I'm going to use the LOG log, and I'm going to put that on both sides. So we've got our 3 to the x minus 4 and our 7 to the 2x plus 5, and all we're going to do is we're going to take the LOG log of both sides. That's all we're going to do to start. Now the question is, why would that help us? Well, there was one special property of logarithms, and that was if you have an exponent inside of a logarithm, what can you do? Exponents inside of a logarithm can move out in front of the logarithm. Now, keep in mind, when they're an exponent, they're already being held together because they're all itty-bitty things being held up in the exponent. So when they move out in front of our log, we still need to hold them together. How do we hold them together? We pick up parentheses. So when I move those exponents out in front, we have to pick up parentheses. So that first exponent moves out in front as an x minus 4 with parentheses. the log of 3 stays right there next to it. On the other side, the exponent, the 2x plus 5, moves out in front, and the log of 7 stays where it is. Okay, the question is, how does that really help you? Well, we have to think about this more logically, that log 3 and log 7, even though they look funny, are just numbers. And if we have numbers multiplied by a set of parentheses, we normally do what? Without thinking, we distribute. And that's what we're going to do. So we're going to multiply the log 3 out to everything on the left. So the log 3 times the x, nothing you can really do with that. We'll leave it as x log 3. Then we have to do the 4 times the log 3, which will give us a negative 4 log 3, equals, now I need to distribute the log 7 to everything on the right. So the log 7 times the 2x will give you 2x log 7. Not pretty, but there it is. And the log 7 times the 5 will give you 5 log 7. Now, what was the point of all this? Well, we're solving an equation for x, so we need to get the x's by themselves. Right now, we've got x's on 2 sides of the equation. We've got one on the right and one on the left. Well, so let's work on getting both of the x's on the same side at least. So, it doesn't matter which one you move. I'm going to move the one that's on the left over to the right by subtracting an x log 3 from the left and the right. That will move it from the left to the right. Problem. Now they're on the same side. You still can't actually subtract them though because they're not like terms. But at least they're on the same side. So I do have the 2x log 7 minus an x log 3. They are on the same side at least. Well, the other problem is I have this 5 log 7 on the right, and I don't want it with my x's, so I'm going to move it to the other side by subtracting a 5 log 7. But again, if I do it to one side, I'm going to have to do it to the other side. So that will move it from one side to the other. Now at least all the regular numbers are on the other side. Again, they're not like terms, so you can't actually put them together, but at least now they're on the same side. We've got a negative 4 log 3 and a negative 5 log 7. Messy as it is, at least they're on the same side. Same thing with the x's. Now, there is a trick, and we've used it once before. So, we've got 2 terms with x's. That's what we're trying to solve for. They're on the same side. We cannot put them together because they are not like terms, so what's the trick? Well, I have them highlighted for a reason. It's good old factoring. We have an x in both terms, so we can factor out an x. So if you factor out an x from both pieces, what will you be left with? You'll be left with a 2 log 7. 2 log 7 minus, we'll have a log 3 on the last piece. The other side isn't even changing at all yet. All we did was factor out a x. Now that I've got the x factored out and a set of parentheses next to it, how do I get rid of that piece that's inside the parentheses? Well, remember that the parentheses mean multiplication. So how do I get rid of that multiplication? Well, luckily I can just go ahead and divide by that huge, awful piece. I can divide by the 2 log 7 minus log 3 all at once, as long as I do it to both sides. The 2 log 7 minus log 3. And that will get rid of that whole awful piece in one fell swoop and just leave you with the x. So what this gives me is that my x equals negative 4 log 3 minus 5 log 7 all over 2 log 7 minus log 3. And if they are asking for an exact answer, that's it. And you are done. It looks awful, but you can't do anything to help that answer at all. Now, they could ask you to plug this in your calculator. If you do plug this into your calculator, you do need to put parentheses around the top and parentheses around the bottom so that you make sure that your calculator calculates the top and the bottom first, and then it will do the division last. Just a warning when you're typing this into your calculator. Now, like I said at the beginning of this problem, we did LOG. You could have done this exact same problem with LNs. You would have gotten the exact same answer, except for everywhere you see a LOG log, you would see a natural log, an LN instead. So the other answer that you could also get is -4 natural log 3 minus 5 natural log 7 all over 2 natural log 7 minus natural log 3. They're exactly the same. It's just LNs instead of logs. Nothing else would be different. Now let's